Do you remember what hypothesis testing was? Guys, do you remember that? What was the thing that we were doing? We were creating a hypothesis, right? We had one null hypothesis and alternative hypothesis. Null hypothesis means like I'm gonna compare something against something, and I'm assuming that they are equal. Okay, my hypothesis is that they are equal. The means are equal. Then I perform the test statistic. I get p-value, and I try to interpret that p-value. And with respect to the significance level, I find I come up with a conclusion. Right? Do you remember all these? Let me remind you some things, like we were converting the research question to a null hypothesis. Null hypothesis usually means no difference in the population. An alternative hypothesis claims that this null hypothesis is false. Okay, it can be either not equal or greater than or less than kind of thing. And then we collect data and seek evidence against the null hypothesis in order to explain our conclusion. Okay, so let us start with this easy question, arkadaşlar. We had something like this before in a midterm or final exam. Let X represent the adult intelligence score. Okay, so people get some tests, and we get some IQ levels, let's say, and then the IQ levels have a normal distribution, and whose mean is 100 and whose standard deviation is 50. Okay, so this is the mean of the population. This is the standard deviation of the population. We take 9 people from Kayseri, and these are the IQ levels of people from Kayseri. Okay, let's say that this is randomly sampled people, and we are trying to find out if this data is coming from this distribution. Okay, our main question is that this data is coming from this distribution. Okay, how would you approach to this problem? How will we do it, arkadaşlar? So we have the mu0 is equal to 100, standard deviation is 15, n is 9, and I have my data. Okay, so from this data, what will I do? I will find my mu1. Okay, should I find this the standard deviation from this data, arkadaşlar? Should I find the standard deviation from this data? Yes, no? No, right? We don't need, because this is given and I only have the data, and I would like to find out if mu1 is equal to mu2 or not. This is my H0, right? This is my H0. What is my H alternative? Mu1 is, for example, greater than mu0, right? Sesim geliyor mu arkadaşlar? Sesim geliyor mu? Evet. Peki. What should I do first? What should I do first, arkadaşlar? What should I do first? Find the mean, right? That means X bar. Find X bar. And then we will come up with a Z value, right? X minus mu0 divided by sigma divided by root n, right? This is what we were doing. So we will find the X bar equals 112.8. The mean of these 9 values is this, minus 100 divided by 15 root 9, which is 3. 15 by 3 is equal to 5. So it is 11.5 divided by 5, right? Something close to 2.56 or something. So this is my z value. From now on what should I do? Arkadaşlar, birinizin mikrofonu açık galiba, ondan şey oluyor. Veya benim mikrofonumla mı ilgili bir sıkıntı var? Tam anlayamadım. So from z, what should I do? I will find the probability, right? From z. From the z table, I will find the probability of this value. And then compare with my confidence interval, compare with my confidence coefficient or my level, like 0.05 or something like that, okay? So this is how we were doing, right? So if you remember, we were doing this. Write the hypothesis, find this z value, find the probability from the z value, which is 0.0052. Bakın burası önemli. This 0.0052 means it is unlikely this sample came from this null distribution. Okay, this is my null distribution. Okay, which is like 100 between the mean is 115 is my standard deviation, and I'm finding a z value which is 2.56, and I find my p value, probability value. This probability value is very low. So I have strong evidence against H0, right? Do you remember these concepts? Strong evidence against H0. So if I have something less than 0.05, then I have strong evidence against H0. That means my this sample is coming from the null hypothesis, the distribution of the null hypothesis, okay? So we have a strong evidence against this hypothesis. Do you understand what I'm saying, arkadaşlar? What did I do? I started with my H0 and HA. I found my X bar. From X bar, I found my Z value. From Z value, I find my probability. And according to this probability level, I'm gonna talk about if, for example, it is between less than 0.05, then I say strong evidence against, right? If it is between 0.05 and 0.10, it is like marginally strong evidence, let's say. Okay, we had such things. Arada kesilmeler oluyor. Ne yapalım? Acaba şey mi yapsak? Bir sesle ilgili bir sıkıntı var galiba gördüğüm kadarıyla. Kamerayı bir kapatalım. Evet, kamerayı kapattım. Bir de böyle deneyelim. Şimdi nasıl arkadaşlar? Seste kesilme oluyor mu? Can you hear me, guys? Is it better right now? Is it better? Yes? Okay. I hope you got the main message, right? Here, it was just a review of the last week, last Monday's explanations. Now, I would like to go to like a little bit more explanation on that. We had, if I have two-sided p-value. Arkadaşlar, when do I say two-sided p-value? Like in the previous case, I had 0.0052. And I said, this is a strong evidence against H0. What is the, why did I use one-sided over there? And why am I using two-sided over here? Why did I use here one-sided? And why am I using two-sided p-values in this case? Why do I do two-sided p-value? Yes, for one-sided arkadaşlar, for one-sided, mu1 is greater than mu0 or mu1 is less than mu0. For two-sided, we say v1 is not equal to mu0. This is my H alternative, okay? So this is my alternative hypothesis. If my alternative hypothesis is not equal to situation like this, then I use two-sided p-value. If I say if this is greater than or this is less than something, then I use one-sided p-value. Okay? I guess you understand this situation. So then I have one p-value here. Then I will multiply this p-value by 2 and obtain my two-sided p-value as 0.01. Then I can compare it with a kind of alpha value or something like that. Okay? I think you remember these topics. And now today, I will talk about the errors, okay? The error types. This is critical. I think we worked on this in a capsule lab a couple of maybe weeks ago, maybe months ago. And we talked about that, but now I need to talk about them in more detail, okay? This is very critical that we talk about type of errors, different types of errors. Then I will talk about the t-test. We talked about z-test until now. Today, I will talk about the t-test after this discussion. So, I have two types of errors, arkadaşlar. One of them is type 1 error, the other one is type 2 error. But before that, let me explain this table to you, okay? So, this is the actual situation. Actual situation. That means actual situation of what? I changed the setup in my factory. Does it affect the production efficiency? Does it affect the number of bad parts, the number of broken parts, or not? Okay, that's my situation. Or I am applying a certain diet, and does it have an effect or not? I am applying a certain methodology, a drug, to my patients. Does it have an effect or not? Does this drug in COVID-19 affect the outcome? Okay, that's something that we are trying to do. And actually, we are saying that there is no effect. Okay, if there is no effect, H0 is true. That means null hypothesis is true. There is no difference between these two cases. Okay, so this is something critical. And on the other hand, if H0 is false, that means null hypothesis is false. Then that means there is an effect. Okay, this methodology, this diet affected the outcome. Okay, so these are the actual situations. How about my decision as the experimenter? I may say I'm rejecting H0. So H0 is not correct. I'm rejecting H0. This hypothesis is rejected. Or I will retain, I will accept it. Okay? There are two cases. I will either, as a experimenter, I will either reject H0 or I will retain H0. For example, we said that probability is equal to 0.0052. What did we say? We will reject H0, right? That's what we said in the previous slides. If like P was equal to 0.15, then we would say we will retain H0. Okay, retain H0. That means we do not have enough or sufficient or strong evidence against H0. That's why we are saying that. Okay, so if there is no effect, but I say there is an effect, reject H0 means there is an effect. There is an effect here. Effect of my diet. Okay? If there is no effect actually, but I say there is an effect, that is called type 1 error. Okay? Burası anlaşıldı mı acaba? My hypothesis is true. Actually, it is true. There is no effect in in doing this methodology or that methodology. There is no effect. But I say there is an effect. Okay? Actually, this drug doesn't help COVID-19 patients, but I say it has an effect on COVID-19 patients. Okay? That's called type 1 error. That means my rejection means that it has an effect. It has a positive effect. For example, this drug has a positive effect on COVID-19 patients. Okay, this is type 1 error. Why is this decision correct? Actually, there was an effect, and I found that there was an effect. My decision is there was an effect, so this decision is correct, right? Actually, there is no effect, and I say there is no effect. Then decision is also correct here. You understand these two decision correct situations, right? There is an effect on there is an effect of this drug on the treatment, and I say yes, there is an effect. There is no effect, and I say there is no effect. So here I say there is no effect. Bakın burası, this is what I say. Okay, this is what I decide. But actually, it may be something else. Okay, I gave this example to you in the class, if you remember. There is an enemy plane coming towards us. Using our radar systems, we might say, oh, this is an enemy. This is a correct decision. I might say this is a friend. This is not a correct decision, right? This is a false decision. So it might be a friend plane, but I might say friend plane or enemy plane. So these are all 4 different options. I might say no effect, and I say there is an effect. Okay, there is an effect or there is no effect, but the actual situation might be this. Okay, how about type 2 error? So type 1 error, what is it? Arkadaşlar, type 1 error. What is type 1 error? I want your responses here using the chat. What is type 1 error? In the diet situation or in the health situation. You're writing, I guess. Yes. So my hypothesis says that this drug doesn't affect. So there is no effect. Yaşar said, although there is no effect, we say that there is an effect. No change. Samet says no change, but we reject H0. Beyza says drug doesn't affect, but we said it affects the treatment. Very nice. How about type 2 error arkadaşlar? Type 2 error. Actually, there is an effect of the drug, but I say there is no effect. Okay, that's called type 2 error. Actually, no effect. Yes effect. I have an effect. Okay, this drug has an effect, but my decision is no effect. Okay. Which one is more dangerous arkadaşlar in terms of treating COVID-19 patients? Which one is more dangerous? Type 1 error or type 2 error? Type 2 error, right? Actually, this drug affects the treatment, give a positive effect on the patients, but I say there is no effect. Okay, so that means the drug that we have developed is actually beneficial, but from my samples, I may say that it doesn't affect my outcome. Okay, this is a kind of explanation of what we have said so far. You may read it once I upload this part to you. Bakın burası kritik. The hypothesis test is structured so that type 1 errors are very unlikely. Specifically, the probability of type 1 error is equal to the alpha level. Okay? What was alpha level? Our confidence level, right? Confidence level. So type 1 error is equal to the alpha level. This is something that we will talk on Monday. Okay? Type 2 error, in fact, the treatment does have an effect, but we don't find any effect. Okay? Type 2 errors are commonly the result of very small treatment effects. Okay? Arkadaşlar, one moment, I will recording. For example, arkadaşlar, I have this kind of a table. Okay? I have this table over here. Okay? Let's say this is cancer, no cancer. Okay? This is the actual situation. Actual situation. And this is cancer, non-cancer. This is my decision. Okay? So I say, out of 100 patients, let's say 50 of them are cancer, 50 of them are non-cancer. Okay? Normally, 50 cancer, 50 non-cancer patients. Okay? And out of 50 non-cancer patients, cancer patients, I found 45 of them as cancer. Okay? And out of non-cancer patients, I found, let's say, 10 of them as cancer. Okay, 5 of them. This is the actual, this is the, okay. This is my table, okay. This is my table. This is also called confusion matrix, okay. So, actually, the patient, like out of 50 patients, I find 45 of them as cancer, and I find 5 of them as non-cancer. Out of 50 non-cancer patients, I find 40 of them as non-cancer, 10 of them as really cancer patients. Can you give me the accuracy level of this decision? I used deep learning, I used some machine learning approaches. What is my accuracy? Out of 100, bakın, this is correct. This is correct. 85 divided by 100, right? 85, correct 45, correct 40. So totally 85 correct decisions and 15 error, right? Error rate will be 15 over 100, okay? But we will also be talking about the probability of finding cancer as cancer, okay? This is something like something as it is. So this is what? 45 over 50. This is 40 over 50, okay? This is true, finding these as they are, okay? So this is what accuracy is. And we may come up with different metrics like specificity, sensitivity, or all those kind of things. But I want you to understand what is type 1 error in this case, arkadaşlar? What is type 1 error in this case? Let's say non-cancer, how can I say that? For example, type 1 error. Actually, there is no disease, but I say there is a disease. Yes, Beyza. Actually, non-cancer, no cancer, actually, no cancer, but what we decide is yes, cancer, right? The person has a cancer. This is type 1 error. What is type 1 error rate here? Type 1 error rate. Actually, no cancer. Actually, no cancer. But I say yes, cancer, right? So, actually, it is not 10%, right? Type 1 error, I know that there are 50 people. Out of 50 people, I found 10 of them as non-cancer. 10 of them as cancer, even though they are non-cancer patients. So this is type 1 error. Even though actual situation is that there is no cancer, but I find them as cancer. How about type 2 error? What is the situation? Actually, cancer exists, but I find decision is what? No cancer, right? What is this? Actually, this person is cancer, but I say there is no cancer. Okay? This is something like type 2 error. This is type 1 error. This is type 1 error. This is type 2 error. Okay, what did we say? Even though the guy is cancerous, I say he doesn't have a cancer. So I don't start the drugs. I don't start the treatment. So this is really risky, right? So I hope you got the main message here in the error types and errors. So I would like to go into the last half an hour. I would like to go into the t-test part. Herkes error konusunu anladı mı acaba arkadaşlar? Error konusunu. Yes. Yes, now t-test is coming, okay? T-test. So we had the z-test before. What was the z-tests? What should we be careful about z-test? The variance is known. As we said in the previous example, 100 was my mean, 15 was my standard deviation. So standard deviation or variance is known. So I use z-test. How about if I don't know what the population variance is actually, right? Which is more usual, more common case. And we talked about that in t-distribution, if you remember. We had 3 different cases, single sample, and we were comparing it with another predefined value. We have independent samples and we have dependent samples, okay? 3 varieties, and I will talk about these varieties in today's talk in terms of hypothesis testing, okay? So in single sample case, I have one group and I would like to test it against the hypothetical mean. Hypothetical means I have it from previous studies, I have it from the literature, those kind of things, okay? In independent samples, I have 2 means, 2 groups, no relation between groups, and these people in 2 groups are randomly assigned to that group, okay? In terms of dependent t, we will have 2 means, either same people in both groups or people are related, such as twins, husband, wife, left, right hand, hospital patient and visitor, those kind of related stuff, okay? So we talked about them again before. What was special about t-distribution, arkadaşlar? What is the difference between t-distribution and z-distribution? Sample size is important. We don't know what the variance is, okay? If the sample size is high, what happens? If the sample size is high, what happens? arkadaşlar, two things are important in Z distribution, Z test. Sample size is critical, and also population variance is critical, okay? So we don't know the population variance, and sample size is usually small, okay? If n goes up, it becomes a Z test or Z distribution, right? If you, very nice, thank you, you remember those kind of things. If the n goes up, that means degrees of freedom goes up, it will be more likely, it will be more similar to a normal distribution, okay? If n is small, the distribution will be more fat, okay? Fat close to the tails. The tails are more fat here, okay? Different than the normal distribution. But if I increase the degrees of freedom, then it becomes a lot closer to a normal distribution. Okay, we remember that. Evet, single sample t-test, something we did before. Can you solve this problem, arkadaşlar? I have how do I start my question? I start my question like that. I have a set of data coming from 25 people, and from that data I found 11 is my mean value, okay? X bar is 11. And I have my data from previous knowledge, and my hypothesis becomes like that. The mean is equal to 10. This is my hypothesis, null hypothesis. My alternative hypothesis is that my mean is not equal to 10. I know from my, I don't know from my previous knowledge, but I know from my data. Bakın, this part is coming from my data, right? This part is coming from my data. This part is my hypothesis testing. I should start with all these from a question, okay? So how will I start my solution, arkadaşlar? Where should I start from? Where should I start from? The value of t. How will I find the value of t? How will I find the value of t, arkadaşlar? I should start with finding the standard error of the mean, right? I should start with this. I should start with finding the standard error of the mean first. 5 divided by root n, which is 1. Yes, Bilal, thank you. X bar minus mu divided by standard error of the mean, estimated standard error of the mean, which is 1. So I find my t value as 1, right? So what was my question again? My hypothesis is, do I retain or reject my hypothesis? Okay, this is my question. Do I reject or retain my null hypothesis? So I find from the t table, okay, t table, my alpha is 0.05. That means 95% significance level, okay? Or my p-value will be 0.05 significance level, okay? Significance level is 0.05, which I determine or which is given to me in the question, okay? This is degrees of freedom, which is 25 minus 1, okay, 24. And from my t table, I find it as 2.064. If it were higher, okay, what is the z value for 0.05? It is this. So they are very close to each other, right? If this were higher, if this value df is higher, then the z value and t value would be very close to each other, okay? This is something that we do. What do we do then? We compare this one. If this is significantly different from this value, so if you remember, that was my distribution, okay? And I say this is my critical point, which is 2.064, and I find my x bar over here as 1. What do I say? I do not have enough significant evidence to reject my null hypothesis. So I retain null hypothesis. Anladık mı arkadaşlar burayı? Çok kolay değil mi? I find x t value. From that, I compare my t with the threshold. And then if this t value is less than that threshold, then I retain 8,0. If this was not 2, but 3, what would I say? It would be somewhere here. Then I would reject 8,0. Okay? So I would say I have significant evidence against null hypothesis, which is saying that mu is equal to 10. If I have 13 here with all the same equal, if this were 13, then I would say I have significant evidence against null hypothesis. Okay? Ömer, yes, 95% is given to me or I assign it. Usually 95% is chosen because it's like an optimum position, okay? It's not 90%, 99%, it is somewhere in the middle. So that's why 95% is usually chosen, okay? So if you remember from the confidence intervals, what were we doing arkadaşlar? X bar plus and minus my t value times my standard error of the mean, which is 2.064. So my confidence interval using t is somewhere between 9 and 13. 9 and 13, right? So my mu is 10. So it is somewhere here. I can say that I have non-significant evidence against null hypothesis. So I retain 8,0. You remember we did something like that in confidence interval explanations. This is like it's similar, but in hypothesis testing concept. Bu single sample t-test anlaşıldı mı arkadaşlar? Single sample t-test. Easy, right? Everybody understood what's going on? Yes? What should I be careful about in the question? Ömer, do you have a question?
Yes, hocam. I just couldn't understand when we will say it is significant evidence.
We will look at there are two ways to do it, okay? Either take this t value, okay? From the t table, check the t value, t is equal to 1, okay? Then find the probability of that t being greater than 1, okay? It will be something like that. Greater than 1 will be my probability. And this will be, let's say 0.2, okay? I'm just making it up, 0.2. Then I will say this 0.2 is greater than 0.05. So I don't have, there is non-significant evidence. There is no significant evidence against 8,0. Okay, this is one way of doing it. The other way of doing it is like, I have a 95% confidence interval, okay, then the confidence level, then I say, is my t value less than my threshold value, which is the t for 24 degrees of freedom, okay? Then I say, this is non-significant. There are two ways again. Find this one, go to the t table, find the value and compare it with 0.05. Or find one and compare the t table value from this 0.05 and 24 degrees of freedom. And if this is less than that, then I say there is no significant evidence against null hypothesis. Anlaşıldı mı acaba arkadaşlar? Both are Evet, let's move on. If I have two means, what will I have? For example, in your projects, you will have two groups arkadaşlar. One group of students, another group of students, males, females. This experiment and control group. Okay, I will have two different groups, two different categories. I want to know the difference in population mean and best case is difference in sample means. So what do I say? What should I put my hypothesis as arkadaşlar? What will be my null hypothesis? What will be my null hypothesis? The difference between mu1 and mu2 is equal to 0, right? The difference between the first group, mean of the first group. For example, weights of the male students, weights of the female students. The means are, the difference between the means are 0. This is null hypothesis. There is no difference between the means of mean weights of male and female students. Do you understand the null hypothesis here arkadaşlar? There is no difference, okay? So I will say, this is my difference. This is the variance of my difference, which we discussed before. And this is the standard error of the mean, standard error of the difference, like that, okay? So our null hypothesis will be like, this is equal to 0. And we will use this standard error of the mean in our calculations, okay? Anladık mı burayı arkadaşlar? So we will go further. What can I say in the next slide? For example, arkadaşlar, this is my, if I have large samples, large number of samples, large number of data in my sample, then I would immediately find, please check the slide right now. And I want you to understand what's going on over there. What is my question? Can you tell me what my question is? I have two groups. One of them has 10 as the mean, sample mean. The second one has 12 as the sample mean. What is my question? Null hypothesis. My question, research question, is the mean of the first group equal to the mean of the second group? Okay, this is my null hypothesis. Or this is my research question is there a difference between the mean of the first group and the mean of the second group? This is my research question. What is my hypothesis? My hypothesis is that, null hypothesis is that the means have no difference. What is the alternative hypothesis? The means are different from each other. But I cannot say by just looking at these values, oh, they are not equal. I cannot say that statistically. Statistics wants us to check whether this is something related to the standard deviation. For example, one of them is like this, okay? The mean is like that, and standard deviation is 2 here. The other one is mean is somewhere here, and standard deviation is 3, a little bit more extended, okay? So I'm trying to find out if these two things are really have really a significant difference between them or not, okay? This is what I'm trying to find. If I have large sample of data, large sample such as 100 like that, okay? Then I can use the Z approach, which we have done before. What is this value, arkadaşlar? What is this value? X bar minus 1, X bar 1 minus X bar 2 is equal to minus 2, right? Minus 2. This part is minus 2. Minus 0. Minus 0 is coming from my hypothesis testing. What is this part? Coming from my standard deviation estimations, which is, bakın, square of this divided by sample plus square of this divided by sample size is equal to 13 divided by 100 square root, which is 0.36. Then I find my z as 5.56, which is way too small, right? In the z, it is somewhere over here, very small probability. So what I say is that the difference, the null hypothesis, I reject null hypothesis. I reject null hypothesis, okay? So H0 is false. Anlıyor muyuz acaba burayı? So from the difference between these two groups, do we know where estimate sigma is coming from? This is explained before. This is like a pooled variance. If you remember this concept, pooled variance. Okay, pooled variance. It's just like I have this variance over here from the first group, this variance from the second group, sorry, this variance from the first group, this variance from the second group, and I Sesim geliyor mu arkadaşlar? İnternetime bir anda kesildi. Ben de telefonumdan devam ediyorum. Sesim geliyor mu? Evet, geliyor.
Şu an geliyor hocam.
Tamam. Bir anda
Ben de sadece
Tamam. Şurası önemliydi. Burayı açıklamak istiyorum. Let me come here. Bakın, what do I say here arkadaşlar? This is a pooled variance. Pooled variance. Okay? So I have my variance here from the first group. This is a variance from the second group. I have a common group like a pooled. Pooled means put everything together, okay? I am using the pooled variance, which is coming from the square root of this plus square root of this square root, okay? This is my variance of my difference, okay? This is where it comes from. So that's why I use the standard deviations or the variance of the groups in order to find the difference standard deviation. Okay. So I hope you get the point, arkadaşlar. Here, what is that I have done here? I say that the number of samples are high. We used Z distribution. If I don't have such a situation, if the number of samples are low, then I use these approaches. Bakın. Okay, I remember that we have talked about these before. This is like, again, pooled variance. We say that the standard deviations are equal. Standard deviations are equal for two groups, but what do we do? We have the N1 from the first group, N2 from the second group, and we find the degrees of freedom like that. And then using this degrees of freedom, we will find out the t values. Okay, so this is pooled variance. It's a kind of weighted average of the variances. Bakın, this is what variance, sample variance of the first group. Sample variance of the first group. Okay, I have N1 people in that first group. and this is the sample variance of the second group, and this is coming from the second group. So I'm trying to find out such one variance value. That's why it's called pooled variance. I put everything in as one variance, which I will use for my calculations. But I'm not using only S1 or S2 alone. I'm not just putting them together. I have some kind of a weighted average. Why weighted? Bakın, if I have 25 people here and 10 people here, so the variances will be affected accordingly, right? So for example, S1 square is 10, S2 square is 5, and there are 15 people here. What do I do? 24 times 10 plus 10, let's say this is 11, and I have 10 times 5, okay? This is a kind of weighted average. That's what I say. I have more 10s than 5s, okay? That's what I do over here. So I hope you get the pooled variance stuff. I hope you got the point here. We have the pooled variance using this approach. And then we find the estimated standard error like that. Bakın, I take this pooled variance here. I take the pooled variance over here and take the square root. Yani aslında şununla şu aynı şey. Okay? Bu 1 bölü falan diye devam ediyor. So that's why we find this pooled standard error, and we will use it. Let me show you one example. Arkadaşlar, I want you to do it on your own. You have all the information over here. What is my question again? From my observations, the first group has a mean of 18, and the variance is 7, and there are 5 people in this group, and there are 7 people in this group with this variance and with this mean. My null hypothesis is that the difference between these two groups are 0. Okay, my null hypothesis is that my means are, there is no difference between the means. Okay, so please start on it, work on it, and then we will discuss after you finish it. Did you understand what I wrote here, arkadaşlar? Did you understand how I wrote t? This is -2. My hypothesis says that this is 0. And I'm using this formulation right now. From the formulation, I write here 4 and 7 as square. 6 times 583 divided by 5, 7 minus 2, which is 10. And this is 5 plus 7 is 12. 5 times 7 is 35, right? And then I will take the square root and then put it over here. So from the difference sigma, I find 147, okay? And from this 147, I found minus 136, okay? Is this significant or non-significant? How do I determine that? Is this a significant evidence or non-significant evidence? If you remember, if my alpha is 0.05, what was the t value? 0.05, comma, degrees of freedom is 10, right? Neden 10? 5 plus 7 minus 2. So this is my degrees of freedom, which is 10. So I will find from my t table this value, and it is greater than this 1.36. So I say this minus 1.36 or 1.36 is less than 1.81. This is what Samet told me from the t table, 181. So that means it is non-significant. I have non-significant evidence against 80, so I retain 80. Değil mi arkadaşlar? Why did I retain 80? I keep it because I do not have enough evidence against it. The evidence, like the difference between these two groups, are equal assumption or hypothesis. I will keep that assumption. I will retain that assumption. Okay? So 1.81 Samet demiş ama ben burada 2.23 olarak bulmuşum. Herhalde yanlış yere baktık. İkimizden biri. Peki. So non-significant evidence against 80. Evet arkadaşlar, ne oldu şimdi? Ne yaptık? What is that we have done so far? We talked about one z-test example. We have done error type discussions, error type. And then we start talking about t-test. What was specific about t-test? Either I have single sample or I have two samples, but they are independent. Okay. The third one is two samples, and they are dependent, right? We have done this. We have found here, we have found the mu x bar and s from my data and compared it with a certain level. If I have two independent samples, then I have the t as the difference, right? x1 bar minus x2 bar minus mu1 minus mu2 divided by estimated sigma difference. And there were some formulations. You don't have to memorize these formulations, but I want you to understand these estimation of standard deviations are like pooled standard deviations. That there is, we say that there is one standard deviation, and some of the standard deviation value is coming from one group, the other one is coming from the other group. Okay. So how about the third one, the last one, and I will finish up over here. Now I have a dependent t value, okay, dependent t. That means two observations have some common issues, okay? For example, they are in pairs, brother, sister, repeated measures, before, after, 2 in 1, 2 in 2, okay? If you remember, we talked about this twin example before, like in terms of schizophrenia problem we talked about twins, of 15 twins compared in terms of the brain portion, right? Do you remember that example arkadaşlar? Schizophrenic, schizophrenic. One twin is normal, the other twin is schizophrenic, and we compare their brain structures. I shot a video and put it and shared it with you before, so please check that if you don't remember that. Şimdi, if I have observations in common, I have one observation here, here, here, here, here, here. Let's say before the diet and after the diet of the same person. Okay, I have the weight of that person before the diet and after the diet, before the diet and after the diet. Okay, there is a paired situation. That's why it's called paired t-test also. Okay, we can also say dependent t-test. Okay, so bakın arkadaşlar, again very easy. My hypothesis testing will be like the difference between them will be equal to 0. Okay, this is my null hypothesis. Okay, null hypothesis will be like there is no difference between these two pairs. That means there is no difference, there is no effect of diet on the weight of people. Okay, so this is something that we will be doing, and I will have the mean of the differences. This is the mean of the differences. Okay, I will find the difference here. I will write the difference. This minus this will be difference here. This minus this will be difference here, or after minus before. Okay, I can determine that. So I will have my differences. I won't be dealing with those anymore. I will only have the difference values. Okay, if you remember again. So this will be my differences, and I will find the difference, mean of the difference, and standard deviation of the difference. Okay, so this is what we will be doing, and estimated standard deviation of the difference will be this SD that we found here, divided by the number of observations. Okay, so I have 1, 2, 3, 4, 5, 6 observations here, and I have 6 people. That means 6 people's weights I'm using. Okay, then my t value will be computed from mean of d minus this. This is coming from my null hypothesis. This will be 0, for example. I will say there is no effect of this diet on the weight, so this will be 0, divided by this S of D, and we will use the degrees of freedom using this formulation, number of pairs minus 1. Okay, do you remember all these arkadaşlar? Easy, right? I hope you do not have any problems with that. Let me finish with this easy question. Okay, so I have a brother whose value is 5, a sister. Okay, let me write over here. This is the pair 1. This is the observation 1. This is the observation 2. And this is the observation 3. There are 3 families. There are brothers and sisters. Let us say brother of the first family has 5 something, 5 kilos, 5 this and that, and 7 out of 10, let's say. This is 7 and 8, 3 and 3. We find the average of these, okay, but we will not be using them, okay. So we will be mainly focusing on the difference. We are not interested in the exact values. Bakın, 7 minus 5 is 2, 8 minus 7 is 1, 3 minus 3 is 0. So this is going to be my difference, okay. So from this difference, I find the mean of the differences, which is equal to 1, right? 2 plus 1 plus 0 divided by 3 will be equal to 1, right? Mean of the sample, mean of the difference of the samples, okay? Paired observations. What is this part? Why am I doing this? Why am I using this? Because I will use this in my standard deviation calculations arkadaşlar, değil mi? So this is my difference, but I will take the difference from the mean. 2 minus 1. 1 minus 1. 1 minus 1 square. Okay? That's why I got 0, 1, 0 and 1. Takip ediyor muyuz arkadaşlar? Benimle misiniz? Koptunuz mu? Var mı bir sıkıntı? Bitiriyoruz şu anda birazdan. So what do I do here? 1 plus 0 plus 1, which is equal to 2, right? This part is equal to 2. What is this part? Degrees of freedom. 3 minus 1, which is equal to 2. 2 divided by 2 is equal to 1. Root 1 is equal to 1. So my standard deviation is equal to 1. What is my estimated standard deviation? Like the standard error of the mean kind of thing. It is 1 divided by n, right? Sigma divided by root n. What is n? Number of samples, number of pairs, 3. 1 over root 3, which is equal to 0.058. So I come to this formulation, then I say d is 1, minus this is equal to 0, 1 minus 0 is equal to 1, divided by this standard deviation, which is equal to 0.58. And finally, I will have 1.72 as my t value. Okay, what is my degrees of freedom here? My degrees of freedom is what? My degrees of freedom is 2. My degrees of freedom is 2, and I will check the t table from the t table 0.05 and 2, which is let's say a high value, and I find t as this, and I will say we will retain the null hypothesis. Okay, we will retain H0 because this value is much less than this t 0.05, 2 value. Okay. So every time we do the same thing, what changes is we use, if it is paired, we use this as one number. If it is not paired, we use x bar 1 minus x bar 2. Okay. Instead of that, we use mu1 minus mu2, which is coming from our hypothesis, right? And the computation of this is a bit changing in different situations, and you don't have to memorize again, but just you need to understand the main logic. If it is if there are same number of samples, we will use the same n. If there are different number of samples in different groups, we will use the weighted average of the samples, variances, and such. Okay, so we find that there is no significant difference between these two pairs. Okay, brothers and sisters. So that's all from today. I hope you guys